Okay, so let's start by deleting some code that I don't think um, we necessarily want to keep around. Um, well, actually, now that I think about it, nah, forget that. We can just start with what we have. I think I will go ahead and delete the creation of these things. Right? We don't really care about that right now. I don't care about doing this input or like having attack right there. But we can go ahead and keep um, the definitions of things in place, right? Um, I don't know. Yeah, we can go ahead and keep all that. I think it's fine. I'm not going to need grid width and grid height anymore. I think we'll go ahead and um, change those up. All right, so what I want to do is go ahead and open up a window. Now, the way that we are going to do that is by using the window managing system on Linux. Now, if we were doing this on Windows or doing this on OS 10 or on an Android device or on an iPhone or something like that, or an Xbox, PlayStation, Nintendo Switch, got to name all the game systems. We would do this differently each way. Luckily for us, this isn't that complicated. So one of the things I'm really going to emphasize in this video and the next few, essentially whenever we're doing things with the operating system, is how to isolate that operating system code from the rest of our game code, right? So really, we are going to have what's known as the platform layer, or maybe this is going to be operating system layer. And then we're going to have the game code layer, and that is pretty much it, right? So these are going to be the two main layers of our program. And the goal is to make sure that the platform is never doing anything game specific. All it's doing is just creating a window and drawing pixels to the screen. And the game code is what's going to tell us which pixels to draw and where to draw them, right? And what that means is that we can do things like input, drawing, audio, like that, um, on our platform specific layer without ever interfacing with the game code specifically, which means that if we need to make this run on a new type of computer, like on Windows, all we have to do is just say, hey, on Windows, we need a way to get input, we need a way to do drawing, and we need a way to make audio. And then the game code isn't going to care about that, right? All the game code is going to do is say, hey, here's some pixels. And then Windows will go ahead and figure out how to draw them. Or Linux will figure out how to draw them, right? So what we're going to start with right now is how to get a window open. So if you are curious about this, we can go ahead and look at the X11 API. Let's see. I'll go ahead and post a link right here. So this is the Windows system that is used by Linux. Now there are other windowing systems that could be used by Linux, but this is the main one that pretty much everyone's going to have installed. If you're using Raspberry Pi, this is the one that you have. I'm using a regular desktop computer. This is what I have, right? So it's a good bet. So what we are going to do is go ahead and include it. So if we go ahead and do some includes right here, we can get x11 slash xlib.h. And you notice I'm using this slash here. That's because this xlib.h is in a directory with all the other xlib things. We'll also go ahead and import a few other things. We'll do x11/xutil.h, and we'll do include x11/xos.h, right? And let's just go ahead and make sure our game still compiles. Let's see. Okay, cool. Looks like everything worked nicely. One thing I'm going to do to just go ahead and make our lives easier is I'm going to create a new file called compile.bash. And this is a bash file, which is something that you use on Linux to essentially run from the terminal, and it does different terminal commands right here. So like gcc is a terminal command, and what I want to do is just go ahead and type this in here. I'm just going to say gcc-o. I'm going to call it like word game, right? Like that. And then we'll say game.c, right? So not a whole lot more than what we had before. I'll go ahead and zoom that in a little bit. And if I want to go ahead and run that, I can just say bash compile.bash, and it runs that command. The reason for doing that is as our project grows, we're going to get more files, and this command is going to be a little bit longer. We're going to need to do more specific things. So it's nice to just have this all stored in one place, so you don't have to keep typing out the whole command every time you restart your computer. You just have it saved to a file on disk, and you just know, hey, anytime I want to make the game, I'll just do compile.bash, right? And it'll work. And we'll see in just a few minutes some of the things that we will be adding to that file and why they are going to be nice to just have saved in one place. So, again, if you want to dig into the manual here, that could be a very good idea. A lot of it will probably seem very foreign and strange to you if you don't have a lot of familiarity programming either in C or at a low level or using the operating system. There's a lot of different ways it can be kind of strange, but that's okay because I'm going to walk us through it. So some of the things we are going to need is a display. We are going to need a window. We are going to need a window attributes, which is we'll just call it the set attributes. We're going to need just the attributes by themselves. We're going to have an X event, and that's going to be doing things like input and output, like, hey, a key was pressed, a key was released, which you might notice we weren't able to do last time using just the C functions like getchar. And then we're going to have, in fact, I don't actually think we need the GC context. All right, so what I want to do here. Oh, in fact, actually, no. I think we do need the GC context. My mistake. I was just thinking about it a bit more. All right. Let me go ahead and see if I can pull up this manual right here. Get an index of functions. So this is a list of all of the functions that we can call in X, right? The X window system. So that's going to be pretty useful. Let's see, do we have a list of types here? Let's see. generic values and types. I think that's what I'm looking for. Oh no, that's not what I care about at all. Well, we can go ahead and just go ahead and start Googling this. We can just say xlib display type, right? Yeah, so we have this thing right here. If we go ahead and look, yeah, this function returns a display. So let's go ahead and look at what that is, if the link actually loads, which it isn't, which is unfortunate. So we'll just, get back into it. So I say we're going to do this first, which is xinit threads. So keep in mind, these are all functions that are defined in xlib. Let's see, init threads right here. So just like when we were calling getchar, getchar and printf and things like that, we're going to be doing, a similar thing, just using these functions in X. So it initializes xlib support for the current threads, and this function must be the first xlib function a multi-threaded program calls. So we probably don't need that because we aren't necessarily multi-threaded. Don't even worry about what that means for right now. If you want to look up multi-threading, then you can go ahead and read the Wikipedia article, but it doesn't matter for us. I'm just going to go ahead and do this right off the bat, because if I don't, then we might run into an issue where we forget to call it later, and then we'll be unhappy. So I'm going to go ahead and just do that right off the bat. Now we're going to say that display equals x open display. I'm going to pass in null, and we can look at why that is. So if we look at open display, it's going to take a display name. And we just don't care what the display name is right now. So we could go ahead and pass something in if we wanted, but for right now, I don't think that we care. And you'll notice that this is this display name is a char star, right? So it's a pointer to a character or a string of characters. And so, we're going to pass in null because we don't have any. All right. Now what I want to do is say that the screen equals the default screen, right? And this is going to take the display. If we look at this right here, this returns the default screen number referenced to or referenced by the open display. So our display has a screen inside of it. It's it's a struct, right? So we can imagine we have a struct display, right, which has some stuff in it. One of them is a screen, right? So I just realized I forgot to make a variable to store screen. So we'll go ahead and do that right there. And the reason that I want that screen is that we are storing that in a lot of places. So if we have this this root window function, which is it returns the root window, which is sort of like all of the windows that things are rooted to. Again, it doesn't really matter for our purposes because we're just going to be running the game in one single window. But if we had multiple windows, like if we were using a web browser, right, where I can go ahead and open multiple windows, then we care a lot about what the root window is. But I will go ahead and just store another variable here to go ahead and record what the root window is. Again, all of this isn't necessarily what we need to do all the time in every single case, but it's good to go ahead and do this stuff. Partially, it's just if you have kind of a set way that you do things and you're sort of preparing yourself for the future, then it is nice if you ever decide you want to add functionality, right? And that way we don't have to go look at this, the whole documentation again. So we'll say that this is going to be the default GC, which stands for graphic context. You see I'm passing in screen a lot of places, right? So if we go ahead and look here, default GC, oops, go ahead. So this, let's see, where is it? Yeah, it returns the default graphics context for the root window of the specified screen. And again, we don't necessarily care so much about what the graphics context is right now. Let's see, let's see if I can find a glossary here. Glossary, it's 11. Oh, that's not it. Oh well. So this is what is all known as boilerplate code. So the idea is that this is code that isn't really doing anything particularly interesting. There's not a whole lot of room for creativity or doing things differently. Like, I can't just say, hey, I want the default GC, but I'm going to pass in 1001 or 1010 right here, right? It needs the screen that the display has, right? So anytime you write code for opening a window, pretty much on any platform that you're going to be doing it on, it's going to be pretty much the same, right? So we don't need to worry about that too much. We can just go ahead and, continue on with this, and we will start to dig in more into what these things do once we actually have a window up. So I'm going to use this function called create simple window, and if we go ahead and look here, create simple window. Now this is a place where it's going to start getting a little more involved. You see, for one thing, it just takes a lot of arguments. And it's also something that we know very clearly this is what we want to be doing. Like, this is the meat and potatoes of everything that we've been working towards, right? So maybe we don't really care about what default GC and default screen mean right away. But we do know that we care about create simple window. So the first thing it's going to do is it's going to take a display and it's going to take a parent window, right? So we'll go ahead and do those. Then it's going to take an X and a Y, and we can go down here and look, and this is the X and Y coordinates, which are the top left outside corner of the window, relative to the root window. In this case, our root window is just going to be the size of the screen. It's just the whole display, right? So let's go ahead and just say we're going to do 0, 0, right? We're going to put in the very top. For width and height, let's go ahead and say we'll do, 400 and 400, pixels. That sounds fine. Border width. Let's go ahead and look exactly what that is. Specifies the width of the created window's border in pixels. I'm just going to say, 1 pixel. That seems pretty small and is okay. And then we are going to be taking the background. Where is it? Right here. Yeah, the background pixel value of the window. Oh, and then the border, which is going to be the border pixel of the window. So let's see. We're going to have this function. Where is it? Black pixel and white pixel. So what we're just going to say is black pixel will do display and screen. So we're going to say that the border pixel is going to be black, and we'll say that the X, Y pixel, again, display and screen number, right? And you'll see that all these are doing is they are just returning us a number which represents a pixel, right? And we don't really care about that for right now, because again, this is just the border and the background color, right? Then we want to do this X map window, right? If we go here, if we look at, let's see, this right here, see, like, okay, right here we have this manual page on creating windows, and it's going to point us that, oh, hey, there's this function, create window. That could be useful. Then if we go to like mapping windows, we might be curious, oh, what does that do? And we can go ahead and look right here. Go ahead and close those. Map window. It maps the window and all of its sub-windows that have map requests. And we might be a little confused what that exactly means. But what it's doing is it is mapping the window onto the screen, right? So we might have created a window, but that hasn't necessarily gone ahead and put it on the screen for us yet. So that is what this is going to do. We're going to say xmap window display and the window that we just created. So again, xcreate window returns us a window, right? Like that. And then what I want to do is just do a while loop and just say while true. We're just going to keep doing that, right? So let's go ahead and run our bash compile. Oh, okay. Unknown error type of CG. Well, that's because it's GC. Silly me. Okay, now we get into the errors that I was expecting. So right here, it says we have an undefined reference to X init threads, X open display, X white pixel, black pixel, create window, map window. And you'll notice those are just all of the functions that we called. So that isn't, that's not a great place to be, right? Or maybe a little confused by that. So let me go ahead and explain why that is. So far, we've been doing these includes, which just go ahead and dump all of the text of this file into our program when it gets compiled, which is the same thing that's being done right here. The issue is that these functions, like xcreate window, is a really big function. It's, probably several hundred lines of code, maybe even 1,000 or 2,000 lines of code. That's going to be doing a lot of things. So what happens is this function gets compiled, essentially when you install the operating system, right? Maybe not exactly then, maybe even it's compiled, into the operating system when you install it. But it's already translated into machine code. And all of this .h file is doing is saying, hey, we have this thing called xcreate simple window that we already compiled. Just go ahead and know that this is the name, and anytime you want to use it, call that name and look it up in this program that already got compiled. This is what's known as a library, right? So if you've ever seen the term library used in programming, that's what they're talking about. They're talking about a library of functions that is a separate compiled program that you are then going to access parts of, right? So what we want to do to get access to this is we want to use this -L argument to GCC, and that stands for link. And that's going to say that we are linking against a compiled program. In this case, our compiled program is X11. So we're saying, all right, hey, we might have all these names, xinit threads, because you'll notice that it's not saying, like if I go ahead and right here, let's look at xinit threads. Let's just say I call a function x blah blah blah, like that, and then I go ahead and compile. It's saying right here, an implicit declaration of function, blah blah blah. There's an undefined reference. It's saying this. Let's see, where is it? This whole thing, it's saying, hey, you know what? We don't have a function that's called this. We don't know what you're talking about. Whereas these errors, it was saying, hey, we do know what you're talking about. Like, we know that this thing might exist, but we don't know where it is. So if we go ahead and save that and then run it, now it's not complaining about those things anymore because it knows where they are, because we linked against this library. Now, linking can get a lot more complicated. Like, what if you want to link against a program that you wrote yourself? How do you do that? Well, we can get into that in the future. For right now, it's not super important. We're only going to be linking against things that other people have written and that are part of the operating system. Because we want to keep our dependencies as minimal as possible. We don't want to be bringing in lots of other people's code. So now, let's, I called it word game, right? So let's go ahead and see what's going on. Well, doesn't look like anything. I mean, we're looping. The program has started, but it looks like we have not actually started drawing the window. Does it? So let's go ahead and just make sure we haven't completely forgotten to do something. We can go ahead and look at this manual here. I think this will be a good exercise. So after we map the window, let's see. What am I looking for right here? Yeah, so it may not be visible on the screen for one of the following reasons. It is obscured by another opaque window. Well, that's not the case for us. We open the window. One of its ancestors is not mapped. Maybe that's it. It is entirely clipped by an ancestor. So let's go ahead and make sure. Well, first of all, let's go ahead and make sure we didn't open a window of size 0. It's going to be the X and the Y, the width and the height. Okay. Cool. This may be part of the issue. Well, I'm going to go ahead and just continue with what I was doing and go ahead and see if any of this is what's happening. So, first of all, let's go ahead and do this, where we're going to say if display equals null. So remember, xopenDisplay is returning us a pointer to a display. So again, the operating system is handling creating that display. It's handling where that display is stored. It's just going to tell us where it stored what it had for us, right? So I want to say that if display equals null, in all caps, there was an error opening display. Like that, right? Let's go ahead and compile it. Well, okay, so we know we opened the display correctly, right? And we know that we are going ahead and doing all of that correctly. Okay, well, I'm going to sort of do this from memory, and hopefully the following things that I do should go ahead and help us out. So one thing that we are not doing is we are not going ahead and setting the foreground and the background. Oops. Let's see, set foreground. So what this does is, that just says that it can do something. Maybe set background will help us out here. So, well, okay, so these are terrible descriptions, but what they're going to be doing is setting the background and foreground colors of the screen, right? So if we go ahead and run that now, well, it looks like we still aren't seeing anything. I'm just making sure it's not open on my other monitor. We are definitely looping forever. So let's go ahead and check map window, because maybe our map window function returns something bad. So we can go ahead and look at so let's see. I'm just going to go ahead and Google for this real quick. I feel very silly for not knowing this. X create simple window, no window showing up. Because I don't want to go ahead and show you all the other things before making sure that we get our window showing up. Well, I guess one thing that I could definitely try is maybe doing it at 0 and 0 is bad. Let's go ahead and try that. Well, that doesn't seem to have helped. Maybe I'll just go ahead and try doing this not from Emacs. Let's see, 2018 game. Okay, so that has nothing to do with it, which is good to know. All right. So with this sync. Well, okay. Rather than waste your time just by looking at my old code that worked and trying to see what I forgot to do here, I'm just going to go ahead and stop recording and look at that real quick. And when I come back, I will have the answer. Because this is one of those programming problems where probably watching me solve it yourself is not going to help give you a very interesting insight into how to solve programming problems. It's just going to be a lot of me reading source material.